Thanks for watching my video today. Let's see our Ramanujan integral. Okay. Now we are going to evaluate that the integral from 0 to infinity e to the negative ax cos alpha x minus e to the negative bx cos beta x upon x dx is question mark. Okay. Now if you look this one carefully, it is something like we can use the Frullani integral, right? So okay, let's check it out. To prove this, let our integral to be I. So I is the integral from 0 to infinity e to the negative ax cos alpha x minus e to the negative bx cos beta x dx upon x. Okay. Now using that the Euler identity, then is e to the negative ix is cos x minus I sin x. This one, right? Cos, both are cos. So we are going to take the real part here. Okay. We are going to change cos to this exponential, and we are going to take the real part because cos is the real part, right? Imaginary part is sine. Okay, now I is the real part of the integral from 0 to infinity e to the negative ax e to the negative, here x is nothing but alpha x. Okay, alpha x minus e to the negative bx e to the negative, here x is nothing but beta x, I beta x. Okay, according to this one, right? From this one, here is imaginary number is there, right? So from this we are going to take out the real part only. So that means we can get the answer or to our question. Okay. Now combining these two using the exponential law, right? So our integral I is the real part of integral from 0 to infinity e to the negative a plus I alpha times x minus e to the negative b plus I beta x dx upon x. Okay. Now this is we can use our Frullani integral, right? So then is according to Frullani integral we have that integral from 0 to infinity f of ax minus f of bx upon x dx is f of infinity minus f of 0 log of a by b, right? Here if f of x is nothing but e to the negative x, right? And f of infinity, we need infinity, right, is 0 because e to the negative infinity is 0, and f of 0 we need, so f e to the 0 is just 1, right? Here a is nothing but, here a is a plus I alpha and b is b plus I beta. Okay, not that, just a and b. Therefore our I is nothing but the real part of this infinity, f of infinity is 0, right? Minus f of 0 is just 1, 0 minus 1 log of, here a is nothing but a plus I alpha, b plus I beta b. Okay, which is negative times the real part of log of a plus I alpha minus log of b plus I beta, because using the log property, then is log of a by b is log a minus log b, right? Now I think I have already done that. Okay, how to take out from this log, how to separate this the real part and imaginary part. Okay, then is already done. So here I'm not going to solve that. Okay, you can check out that description box, I will be given the link there. Okay, so log of real part times real part plus imaginary part is nothing but this here, log of x plus iy, okay, is nothing but 1 by 2 log x square plus y square plus I tan inverse of y by x. Okay, this is the real part and this is imaginary part. How to extract them. So now let's come back to our integral I is nothing but negative real part times log of a plus I alpha, right? Then is 1 by 2 log of a square plus alpha square plus I tan inverse of alpha by a minus log of b plus I beta is b plus I beta is nothing but 1 by 2 log of b square plus beta square plus minus, because of this minus, okay, minus tan inverse of beta by b, I think, right? Beta by b. Therefore I is nothing but negative real part times these two. If you see this log and this log, so 1 by 2 is common, so 1 by 2, and log of this minus log of this is nothing but log of a by b, right? And is log of a square plus alpha square by b square plus beta square, plus here also this and this are same thing, I imaginary part I, and you will get tan inverse of alpha by a minus tan inverse of beta by b. So if you use tan inverse of x minus tan inverse of y, then you will get this one. Okay, if you apply that formula, tan inverse of b alpha minus a beta by ab plus alpha beta. Okay, now here the real part is nothing but this part, right? Therefore our original integral is, we are going to extract the and this real part, then is cos, right? Therefore the real part is this one. Therefore our answer to this question will be integral from 0 to infinity e to the negative ax cos alpha x minus e to the negative bx cos beta x upon x dx is negative half time log of a square plus alpha square by b square plus beta square. Right, now again, so since here we have real part, imaginary part, so if you extract for imaginary part, so this negative and this negative will cancel, right? It will be positive. Therefore the integral from 0 to infinity e to the negative ax sin alpha x minus e to the negative bx sin beta x upon x dx is the imaginary part, then is tan inverse of b alpha minus a beta by ab plus alpha beta. So the use of this Euler identity is very helpful, right? So if you can calculate for the real part, then imaginary part is already there, right? So this is another integral for this Ramanujan type. Okay.